and then 2 plus. In other words, the oxidation half reaction has to occur 5 times in order for the reduction reaction to get the electrons that it craves. Continue. The question, to me anyway, is why does this reaction work? Why does the one reaction want to give up its electrons and the other one wants to accept them? We will cover that in just a minute when we deal with voltage and reduction potentials. Now that we have a reaction to work with, let's briefly analyze it. The fact is that we could throw MnO4 minus, and we'd probably throw some speculator ion in front of it to make it look pretty. KMnO4. For example, into water with...
Oh, syntax is so important.
I'm sorry.
KMnO4, for example.
KMnO4, for example, into water with Fe2+, and the above reactions would occur. The question is, what good would that do to us? Truth be told, we don't want to waste our time with the reaction unless it is going to do something for us. We are a little ugly that way.
Okay, so, let me tell you what we're going to do now. You realize that the only interaction that these two reactants have, MnO4 minus and Fe2 plus, is that Fe2 plus is giving an electron to the MnO4 minus. Actually, it ends up giving 5, but it runs through its reaction 5 times. That's the only interaction they have. So people are like, okay, well that's grand, but what if we took the Fe2 plus and put it in one container, and the MnO4 minus and put it in another container, and since electrons are the only thing that are moving back and forth, if we put a wire between one and the other one, then couldn't we have the reaction still go? And lo and behold, yay, it did, it worked. So they were able to have 2 separate containers, put a piece of wire in, and the electrons would transfer from one side to the other. Now, as most of us understand that something doing something, unless it actually does something for us, you're terrible at whispering. Terrible. Jackie enjoyed it though.
I didn't say anything.
I know, but she enjoyed it.
I was actually whispering to her.
What's that? But he was overhearing, and, sorry, she was overhearing. He was being, that was good. I was kind of stoic because you saw I was kind of looking at you.
Where am I?
Oh, I'm being filmed here. That's wonderful. That's good to know. So evidently, whatever Andy says is way more important than anything I can ever say. All right. So now, as we come back, oh, you're still talking? Gotcha. Here's where we're kind of ugly this way. Yeah, we can pass electrons from one container to the other. Then we're like, what if we were to put something in between? Couldn't we run out of electricity? And incidentally, do you realize that electrons running through something, we call that electricity? That's what electrons are. That's what electricity is. Odd, that'd be electricity with electrons that are being passed back and forth. But electrons get transferred through something. And in the simplest example I gave the other class was, if you take like one cell and another cell, and you have a wire between them, you'd be like, oh, sweet. And you put like a bulb, like some sort of light bulb in the picture, and the light bulb will go on. And you're like, hooray. Now, lest you think that everything we're covering right now is stupid, and why do I need to know about light bulbs? Everything that you own, every PDA, everything that you have is powered by batteries that follow the exact same principle. A little more complex in their arrangement, but cells in a battery, you have a higher potential cell and lower potential cell, and electrons want to travel from the one cell to the other. So instead, what we do is we put a wire in, aka the positive and negative ends, attached to something else, and electrons have to run through whatever we make it run through, be it your iPad or your whatever. So as we're going through this, the kind of cool thing that I like about this stuff is that it has so many practical applications. We're going to figure out like what batteries actually do. What happens when your phone's recharging? What is actually happening there? Things like that. And lest you scoff at this, I think I said to the other class, can you imagine what your life would be like for 1 week if you were not allowed to have any personal electronic devices? How would you survive? You wouldn't be able to like tweet her, or you wouldn't be able to Facebook her, or you wouldn't be able to like words with friends.
Oh.
No Russell?
I couldn't Instagram, I'd die.
Without batteries or without people, without it's great. It's a good feeling after all.
Insta.
I feel
Read
like
all
we've gone off
about
track
it.
a little bit, so we're coming back. So what we discovered, and by we mean other really smart people, you're not even trying to hide talking. You're just kidding. You know what? Why even bother? You at least, you know what? Thank you. Thank you for at least trying to whisper. This one didn't even bother to try to whisper. Was it interesting?
Yeah.
And now I wanna know, what did she say?
No, I just said I can't survive in Spanish, because she said that she went without her phone for 2 weeks.
What are you doing in Spanish class with the phone?
What?
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 No, she said, no,
You're
she,
saying,
I said in Spanish that I couldn't survive. In Spanish, I didn't say it in English.
She
I
said
said
in
in my
the
brain.
Spanish language.
That.
Yo no puedo.
No, like some, I don't even know.
You getting all this? Getting all this?
I
Got it.
think we've digressed a little.
You miss us, don't you? Anyway, and coming back. So, what we discovered was, hey, if you take one cell, we'll call it a cell from now on, and you had Fe2 plus in it, and you have another cell with MnO4 minus, or you have anything in there, and you put a wire between it, electrons for an instant would shoot across, and then they stop. The way we know this, let's say we got a little light bulb, the light bulb would turn on and then be like, and be done. Which is not an effective way to have a battery. If your battery lasts like a second or a portion of a second and that's it, you would be a sad panda. Or an angry panda, I'm not sure which one. Probably an angry panda. So, so scientists were like, okay, what do we do? And so the answer to this was something called a salt bridge. Now, what I'm going to do right now is I'm going to pause on the lecture portion of this right here. I'm going to pause because it's actually a little bit more. I think we started covering that today with you. So on Monday when we go through this, I'm going to actually start talking about how cells work and why it is that they stop and how do we make them go, and that involves salt bridges, etc. So we're good with that. The homework's going to be just more practice. It's 29 through 32. And I'm going to let you guys work for another few minutes. I don't think you necessarily should leave early. That's all. Work.
And